Hey guys, in this video, we're gonna build something very cool. It's a peer-to-peer chat application with no server, no cloud, and no centralized anything. Just pure peer-to-peer communication. We're gonna use a framework called as Hyperswarm and a sleek new runtime called as Pure.
What makes this special is how minimal and powerful it is. With just a few lines of JavaScript, peers can discover each other using a shared topic and shared chatting directly. No backend, no database, just a swarm of peers talking to each other.
We are going to be using Pure, which is a runtime optimized to build decentralized applications. Think of it like Node or Dino, just with networking and discovery baked right in. I got first introduced to this topic by a workshop from David Mark Clements. This fantastic workshop opened my eyes to the capability of the peer to peer tooling. Whether you are curious about building a decentralized system, or just want to explore beyond a client and server model, or just want to build something very cool and fast, this is the video for you. By the end of this video, you will have a fully working P2P application, all with JavaScript, no infrastructure. So let's jump in.
To get started, we will run npx peer in the terminal. This installs the peer runtime and sets up a minimal development environment for building peer-to-peer web applications. We are kicking things off with good old peer init. Boom. It scaffolds a nice little project with multiple files in it. As you can see, we have 4 files right here, including package.json. Let's quickly get into Visual Studio Code. Let's check the package.json. Nothing interesting right here, just bare minimum dependencies. Let's also check through the index.html. We have nothing special except one HTML element. Let's quickly run the app and see what it does for us. Now check this out. This is just an h1 element, right? Seems innocent enough. But click it. Boom, it's a peer now. We also have Chrome DevTools right here. I'll quickly install few packages. So I'll copy this raw HTML file and quickly paste it in the HTML uh, file, so I don't waste time in writing this HTML code. So I'll quickly preview it to show what it does. So basically we have a simple two buttons. One is for create and join with a text input, plain simple. I'm gonna import Hyperswarm and crypto package for some randomness, and B4A for buffer conversion. I'll add some code in order to have the graceful shutdown of my application. I'm gonna import something from peer. Peer is a global variable available throughout the project. I'm gonna import a function named as teardown. So I'll initialize a swarm cluster, and once application is shutting down, I'll destroy the initialized swarm cluster. I'll also add logs so that we can debug easily. Swarm takes few functions. The main one is the connection. So once the peer connects, it will run this particular callback. So whenever there is an update on the peer, so it will call this particular callback with swarm.onUpdate method. And the swarm.onConnection method, you can add few of this callback. It's called peer.onData. This is basically a trigger when a message is sent by another peer, and I'll also add two of the methods called peer dot on a end, and once there is an error if in the peer connection. So let's quickly test out the code. So in order to test it, we need to enable this create chat room button. So I will add an event listener for it. I'll quickly remove this unnecessary code. I'll add a create chat room button function. So I will generate a random hash with crypto. We'll initialize a topic buffer with 32 bytes of random bits, and we are gonna convert the buffer into an hex string. For now, let's console log the topic. Let's connect this create chat room function to the event listener that we have created, and let's test it out. After the topic has been created, I I just don't want the user to be just creating the topic. I also want him to join the particular topic. So let's create a join swarm function. There is a method that swarm offers. It's called dot join method. So here we pass two parameters called client and server. The beauty of peer-to-peer communication is basically it can act as a client and a server. That means since there is no centralized entity, by awaiting on discovery.flushed, we are awaiting until the user has been joined the swarm cluster. Let's connect the both functions. Let's also add feedback so that we can see in the UI. So I'll check the structure. So we have a loading UI as well. So I'll quickly connect it. I'll play around with the CSS classes. I'll hide the setup block and enable the loading UI. Once the user has joined, I'm enabling the chat block. The chat block as topic and peers. Let's update the topic. Again, I'm gonna convert the buffer to hex string. Let's also add logic to update the peers. So in swarm.onUpdate function, we'll set this in a text of peer count. So this peer count is nothing but this particular swarm cluster. You can get that by swarm.connection.size. Let's also add logs for it. Let's quickly check it out. I'll click on create button. We have the loading UI, and then we have the topic added, and there are 0 peers. So in order to test the peer being connected, we also have to enable the join chat function. I'll quickly add the event listener for it. We'll grab the value from the text input that we have right here. I'll quickly replace the selector, and we will use the same join swarm function by converting the topic buffer and pass into it. Let's run two instances of our application in order to mimic two peers. In one of the instance, I'll click on create. I'll copy paste the topic in the other instance. So as you can see, the peers count has been incremented. That means we have a successful connection. So let's add the messages form functionality. Let's add an event listener for messages form. Let's quickly grab the CSS selector. I'll add an event listener for a submit event. Let's write a function called send message. So once the form has been submitted, I want this function to be triggered. Let's grab the message from this message input. Once I submit the form, I want the messages to be sent to all the peers in the topic. So we can do that by this method. So let's test this out. Remember, I'm consoling log for now. Let's also add an on message function. So it will take two arguments from and the message itself. I'll create a div element and append it to the messages block. Let's connect this on message function to the send message function. So whenever I send the message, it should be me and the message. Let's also add whenever I receive a message. So in order to have the name of the recipient, let's grab the peer's remote public key, and we are gonna use the starting 6 strings. Let's also console log the name. Let's connect this name to the on messages send function. So first I have to convert the remote public key to a string. Let's fix a few errors here. Substring should be all small cases. Let's quickly run this application. I have 2 instances right here. I'm going to follow the same procedure. I'm going to create a topic. I'm going to share this topic with other peer with, so here we have successful connection. We'll send out a first hello. So we have the same hello being received by another peer. We'll reply back with hey man. So here we have a successful connection and a successful peer-to-peer communication. Let's make it fun, and let's add this name generator function that I generated by ChatGPT. So basically it gives cool names based on an X string that I pass. Let's pass uh, this remote public key to generate nice names for hex function. Let's quickly spin up the 2 instances again. So I'll create a topic and share it with my peer, and my peer joins the same topic, and we have a successful connection. We also have this amazing new name called Azure Whisper. Let's send back from this peer. So also we have another nice name called as Golden Horizon. So here we have an amazing peer-to-peer communication. That's very powerful, isn't it?
Isn't that a cool application? So until next time, bye.